For this question, we want to solve the logarithmic equation. Log base 5 of 5x minus 8 equals 3. Above our question, I've written some techniques or methods for solving logarithmic equations. We have two main techniques. One of them is to convert to an exponential equation. We would start off with a log equation, y equals log base b of x, and convert to an exponential, and this is using the definition of a logarithm. We've got the base of the log being the base of the exponent. The log always equals the exponent, so y is our exponent, and what's inside the log is what our exponential expression equals. So this method requires that the logarithm be isolated on one side of the equation. We convert to an exponential using the definition of a logarithm. And then we're going to solve whatever equation is remaining. The other method is using the one-to-one property of logarithms, and sometimes this is called the property of equality. So symbolically, we would have log base b of u equals log base b of v. And then this property of equality, or the one-to-one property, would allow us to simplify the equation because what's inside the log on the left must equal what's inside the log on the right. So that would leave us with the equation u equals v. This method requires the logarithmic equation to have a log with the same base on both sides of the equation. And when the bases of the logs are the same, the expressions inside must be equal. And that's because of the one-to-one property, or the property of equality. And then we'll solve the remaining equation by isolating x. So for our question, we have log base 5 of 5x minus 8 equals 3. And based on these two methods, we can decide which method is appropriate. The first one requires that the log be isolated on one side of the equation. We have a log that is isolated on one side of the equation. The second method requires a logarithmic equation to have a log with the same base on both sides. We do not have a log on the other side that has the same base of 5. So we're going to be using the first method of converting to an exponential. So we're going to take our log equation and rewrite it as an exponential. We have the base of our log will be the base of our exponent. The log always equals the exponent, so this log equals 3, that will be the exponent. And then the expression that's inside the log, 5x minus 8, is what our exponential equals. So we've converted from a logarithmic equation to an exponential equation using the definition of a log. And now we're going to solve the equation that's left. We have 5 to the third power, that's 125, equals 5x minus 8. And I'll solve by adding 8 to both sides. This gives me 133 equals 5x. I'll divide both sides by 5 to get x equals 133. Now with every log equation, you do need to check. You need to check to make sure that you never take the log of a negative. I'm going to check x equals 133 by substituting it into the original equation. Excuse me, that should be 133 over 5. minus 8 equals 3. The 5's cancel, and you've got log base 5 of 133 minus 8 equals 3. 133 minus 8 is a positive value, and we're taking the log of a positive. So let me correct my mistake here. That's 133 over 5 will keep because we have the log of a positive. So this is our solution, 133 over 5. For this question, we want to solve the logarithmic equation. Log base 6 of x plus 8 plus log base 6 of x minus 8 equals 2. So once again, I want to remind you of those techniques that we talked about. These are methods for solving logarithmic equations. And as we said, the first method requires that you have a log that is isolated on one side of the equation. We don't have that. We have two logs that are on one side of the equation. The other method requires that you have logs on both sides of the equation that have the same base, and we don't have that either because on the other side of the equation we don't have a log. However, it's going to make more sense for us to use the first method, even though we don't have a single log isolated. We do have some properties of logarithms that allow us to condense logs to a single logarithm using properties called the power rule, the product rule, and the quotient rule for logarithms. So we'll start off by condensing these two logs using the product rule. That'll condense to become log base 6 of x plus 8 times x minus 8. And the reason why we condense to multiplication is because we have addition and these have the same base. So that's what allowed us to condense using the product rule. But now we do have a single log on one side of the equation, and so we're going to be able to use this first method, and we're going to convert our exponential into a logarithmic, we're going to convert our logarithmic equation into an exponential. So to write this as an exponential, we're going to use the base of 6. We're using the base of our logarithm as the base of our exponent. The log always equals the exponent. So this log equals 2, so we'll have 2 as our exponent, and then the expression that we have inside the log is what our exponential expression equals, x plus 8 times x minus 8. So we've converted our log equation to an exponential, and we're going to solve the equation that we see here. 6 squared is 36. We can multiply out x plus 8 times x minus 8. That's x squared minus 8x plus 8x minus 64. This gives me a quadratic equation, and I'll move all the terms to the same side. So I'm going to subtract 36. And I have 0 equals x squared minus 100. And we can factor this. This is a difference of squares, and it factors to be x plus 10 times x minus 10. We can set each factor equal to 0. to get x equals negative 10 and x equals positive 10. We do need to check these solutions to make sure that we don't take the log of a negative. So let's check the first one. Let's check x equals negative 10 in the original equation. That would be log base 6 of negative 10 plus 8 plus log base 6 of negative 10 minus 8 equals 2. And we can see that negative 10 plus 8 would be a negative, and negative 10 minus 8 would be a negative. So we'll need to throw that solution of negative 10 away. Let's check the other one. So we're doing that. We're throwing that solution away because the log of a negative is undefined. Also, the log of 0 is undefined. So we'll check x equals 10. We have log base 6 of 10 plus 8 plus log base 6 of 10 minus 8 equals 2. 10 plus 8 is a positive. 10 minus 8 is a positive. And so we're going to be able to keep that solution of x equals 10. So the only solution we have for this logarithmic equation is x equals 10. Thank you for checking out my videos. Have a great day.